So we got to abstract classes and members. In this video, I'm going to talk about the abstract modifier that can be applied on classes and their members, including methods and properties. And then I will tell you about the rules that you need to know about abstract classes and members. So what does the abstract modifier do? The abstract modifier indicates that a class or a member is missing implementation. It's easier to explain this with an example. Here's the example we had earlier in this section. So we have a shape class with a draw method that is declared as virtual. And we have a circle class that derives from the shape. In the circle class, we override the draw method. And here we provide the implementation for drawing a circle. Now here we have a problem. The problem is that it's hard to define an implementation for drawing of a shape. How do we draw a shape? It doesn't make sense. When we're talking about a circle, we know how to draw a circle. Or when we are talking about a rectangle, we know how to draw a rectangle. But it's impossible to define how to draw a shape because the concept of shape is too abstract. In situations like this, a better approach is to use the abstract modifier. So we can declare the draw method as abstract to indicate that this method is missing implementation. And we leave it to the derived classes to provide an implementation for this method. So to use the abstract modifier, the code changes to something like this. Note that here the draw method is declared as abstract, and that's the reason it doesn't have implementation. So it doesn't have a body. It's just a declaration. And here we terminate the declaration with a semicolon. When we declare a method or a property as abstract, the class that contains that needs to be declared as abstract as well. So here, the shape class is declared as abstract. With this declaration, we are telling that the shape class is missing implementation and that implementation needs to be provided by its derived classes. In a derived class like circle, it simply override the abstract methods in the base class. So abstract methods are inherently virtual and can provide polymorphic behavior, as you have seen earlier in this section. Okay, now let's review a few rules that you need to know when working with abstract classes and members. The first one is that an abstract member cannot include implementation. So as you saw in the previous example, the draw method didn't have a body. It was purely a declaration. The second rule is that if a member is declared as abstract, the containing class needs to be declared as abstract too. The third one is that in a derived class, you must implement all abstract members in the base abstract class. So in this case, our shape method had only one abstract method, that was draw. If it had 3 abstract methods, you had to override all these 3 abstract methods. And the last one is abstract classes cannot be instantiated. So when we declare the shape class as abstract, we cannot create a new instance of shape. So this line will not compile. Now you may wonder, why do we use abstract? What's the benefit? You use abstract when you want to provide some common behavior while forcing other developers to follow your design. What do I mean by that? Well, in our shape example, by declaring the draw method as abstract, we'll make sure that anytime a developer derives a class from the shape, they will provide an implementation for the draw method. If we did not declare this method as abstract and instead provided an empty virtual method, we would run into the risk of a developer deriving a class from the shape without overriding the draw method. In that case, drawing that object would not make sense. It's easier to demonstrate that in the code. So let's start coding. Okay, let's create our shape class first. I'm not going to use the abstract modifier yet because I want to show you the problem and then explain how the abstract modifier resolves that problem. So here our shape can have a few properties. Let's just give it a width and a height and a method for drawing the shape. So as I explained, we cannot define an implementation for drawing a shape. We have to leave this method as empty. Now let's put this in a separate file. Okay, back to our program. Now let's create a circle class. And here we override the draw method. Nothing new so far. So let's just put this in a separate file. Now imagine you're designing this as some kind of framework. So in your framework, you're providing the concept of a shape and a circle. In the future, other developers may extend on this topic. They may define new kinds of shapes. Or it doesn't have to be other developers. It could be yourself. So let's say sometime in the future, you decide to add support for a rectangle. So what happens is we go to the program, create a new class here, rectangle, and derive it from shape. But accidentally, we don't overwrite the draw method. Now let's see what happens. So we go to the main method, we create a circle, we draw the circle, and then we create a rectangle and draw the rectangle as well. Let's run the application. So here's the problem. We get a circle on the screen, but not the rectangle, because we accidentally left out the implementation. So here is where the abstract modifier can help. So we can go back to our shape class and say we have some common behavior or some common properties about the concept of a shape that we implement here, but there are behaviors here that we would like to leave to the derived classes to implement. The draw method is an example of that. So instead of creating an empty draw method here, we can just declare it as abstract. And of course, we need to get rid of the body and add a semicolon here. Note the red underline here. I put the mouse here. Abstract method in non-abstract class. Because the draw method is abstract, the shape class needs to be declared as abstract as well. Now let's add another method here that doesn't have to be abstract. Let's say every shape needs to have the ability to be copied into clipboard. So we can have a copy method here, which simply copies this shape to the clipboard. And perhaps this implementation would be common across all derived classes. We don't need to change that implementation in the circle or in the rectangle. So here we have some common code. Copy shape into clipboard. We could have other methods here like select. Perhaps when we select that shape in our PowerPoint application, we would like to display a highlight around the shape. Select the shape. Okay, now that we declared this draw method as abstract, let's take a look at the rectangle. So here's our rectangle class, and note the red underline. It says abstract inherited member draw is not implemented. So this way we create some kind of safety, some kind of guard. We make sure that everyone, including ourselves, follow the design. So what we do here is we put the cursor here. With ReSharper, we press Alt and Enter. And the first item is implement members. And ReSharper automatically creates override methods for any abstract methods derived in the base class. So let's implement this method here. Draw a rectangle. Now we run the application. Note that we get both draw a circle and draw a rectangle. So here's the benefit of abstract modifier. It's not something that you use every day in your programming career, but it's a tool that you can use when you're facing situations like this, when you want to force your design to be followed everywhere in the code base. Now, before we finish this lecture, I want to show you a couple more things. So first, let's put this rectangle class in a separate file to clean up our code. Back to the program. Look here, I cannot do something like this. We cannot instantiate shape because shape is declared as abstract. And that's the reason we get this red underline here. The tooltip says cannot create an instance of the abstract class shape. Here's yet another reason to use abstract, because what does a shape represent? It's too abstract. We cannot imagine a shape in our PowerPoint application. In our PowerPoint application, we have concepts such as circle, or rectangle, or image, or table. Shape doesn't make sense. We can just use shape as the base class that provides some common behavior, but it shouldn't really be instantiated. So let's comment this out. Okay, in the .NET Framework, we have a class called stream, which is the base of all types of streams. Earlier in this course, I showed you file stream and memory stream. In case you missed that lecture, let's quickly review that here. So we go to View, Object Browser, and here we can type file stream. So file stream is a class that is declared in system.io namespace. And look at the declaration of this class here. So file stream derives from system.io.stream. Stream is an abstract class, which means you cannot instantiate it. Let's take a look at this class. Look, stream is selected here. Here you see the members declared in this class. And here's the declaration of the class itself. It's a public abstract class. Again, here is another example where some concepts needs to be declared as abstract. For example, what does a stream represent? A stream is too abstract, but file stream is very specific. It provides ways to read from or write to a file. Or memory stream is a kind of object that allows us to read data from memory or write data to memory. But the stream itself is just too abstract. So that's the reason the developers of .NET Framework have declared it as abstract. And by doing so, they have provided some common behavior that you can see in some of the methods here, but they left the implementation of some of the members to the derived classes like file stream or memory stream. Okay, that's pretty much it for this lecture. I hope you enjoyed it and thank you for watching.